Hi everyone, I'm Luis from Doxia Studio and welcome to the second part of IntoPopNet tutorials in Houdini. In this tutorial we are going to learn how to use an image and VEX programming to control our particles. Before we start, I want to explain the basic logic that we are going to explore. I want to start our tutorials like this so you understand the process we do before we start an Houdini project. So we are going to use an image to control the movement of our particles. And to do that, we are going to use the brightness of each pixel to control the direction of our particles, right? First, we need to know the position of each particle and extract the color of the corresponding pixel. That will be done with a simple VOP node with a color map. Then, we are going to use the brightness from that color and convert it to direction or velocity. So, we have the brightness from black to white, and we want to convert that value to angles, and because we are going to work with radians, we want to convert the brightness to a value between 0 and 2 pi. This is easy, right? We have covered this on our first tutorial. We have a value that is going from 0 to 1, and we want to convert it to other range with the fit function. After we get our angle from the brightness, we are going to use simple math to convert that angle to a vector. And that's how we are going to control our particles' velocity and direction. So let's start our tutorial in Houdini. Okay, let's start our tutorial. Let's begin by placing a geonode and call it particles. Dive in and let's place a grid. Change the size to 20 by 20. We are going to work with square images and scatter some points. Let's increase the scatter to 10,000 maybe, it's up to you. And let's place our friend pop network. Dive into the popnet and let's do the things we did on the first tutorial, on the previous ones. So let's go to this node, pop source. Let's change the emission type to all points. So it's going to use the scatter points. And the birth we want to emit only on the first frame. Turn off the guides, so we will use the color from the particles. And if I press play, we are going to emit particles only on the first frame, and they are staying still because the velocity is 0. We are not changing the velocity for now. So, let's start, right? First, we need to know the position of each particle and extract the color of the corresponding pixel. That will be done with a simple VOP node with a color map. So let's do that. Let's place a pop VOP and wire this in. Here we have the nodes, the particles and the output. And we want to place a color map and pick our noise image. For example, in this case, I'm going to use the noise _5, and that is this one. We are going to use this image for now. In this case, with color map, we are going to use the U and the V input. How does this node works? Just go to the Houdini documents, and here you have the parameters. And you can see the values on this node work between 0 and 1. But in our case, the position works between -10 and 10. Right? So we need to change the position and change those values to a range between 0 and 1. To do that, we need to place a fit range, just the same as the fit functions we work in VEX. We already know that. So wire the position to the value, and it already says it's a 3D vector, and the first column is X, Y and Z, right? So the source of the X value will change between -10 and 10. Why it's -10 and 10? Because our grid has, I can't go up, okay, because our grid has a 20 size. If I change this to 30, maybe, we need to change these values to minus 15 to 15. Okay, so on the x, in this case, values will change between minus 10 and 10, and we want the destination value to be between 0 and 1, just as the document says here. So every time you don't know something about a node, just go to the Houdini documents and it will explain really simple to you. Back to our code. So on the x it's minus 10 and 10. On y values we don't care about that because we are going to work only with x and z. And the position on z, it will change again with between minus 10 and 10. We want the destination between 0 and 1. Now, to use these values, you need to convert vector to a float, right? We saw that on the first part of IntPopNet. And now we have the x value. We are going to link to u on the color map, and z, we are going to link to the vertical to the v of color map. We are not going to use the y because our grid is on the floor. So we are working with x and z. If I wire these up to the color, you will see our particles change color. Let's go up. I'm going to increase just for now the particles, 8 to 8000, so you can see the colors way better. Okay, so right now we have the same colors as this image, right? So we are getting the color of each pixel depending on the position. But instead of using the color particle and changing the particle's color, I'm going to export this color, this vector, to a new parameter. So let's place a bind export, and this node will allow us to create a new parameter. So let's name it color position, and it's a float, and it will be a vector RGB with RGB colors information. If I go up again, just to explain to you, if I go to the PopNet and press on I, we can see the points attributes. Now we have a new one called color position, and it is a vector with 3 floats, right? So everything is good. We are getting the pixel, the color of each position of each particle, and now we need to change and convert that color, get the brightness, and then convert that brightness to angle, and then again use that angle to change our particle's velocity. In order to do that, let's place a wrangle, pop wrangle, wire this in, and let's start our Vex code. So first things first, as I said, we are getting the color with RGB values. So first we need to convert, as we did on the first tutorial, that RGB color to hue, saturation and value. Let's create a vector, AHV, and we are going to convert RGB to AHV, and we are going to use the new parameter called color position. Exactly the same name as we create on the bind export. Okay? We are going to use this new parameter. So we have a vector with hue, saturation, and brightness. Brightness is the value. So now we are going to get only the brightness. It's the z coordination of that new vector. Okay? So now we need to convert that brightness into an angle. So let's create float angle and use our friend fit function to do that. So the value input to the fit is the brightness. This value will change between 0 and 1, and we want to change between 0 and 2 times pi. Right? So now we have the angle. We need to convert that angle to a vector. So, and that vector will change our velocity, right? So we can do already that. Let's do that. Our velocity will be set some values. If I do this, you'll see our values. Our particles will move along the x-axis with velocity of 1. So we need to change these values using the angle. How do we do that? We are going to use simple trigonometry. If you don't know how to use that, you can just go to our friend Google, and if you didn't study trigonometry, you can just search for convert angle radians to vector. And there are plenty of pages explaining that. On this one, you can see we can get the vectors with cosine and sine values. And the A is the angle in radians, always in radians. In our case, instead of using y, we are going to use the z value. So let's do that. Let's change. On the x, we are going to use the cosine of our angle, right? On y, we don't want velocity. We want our particles to stay on the ground, on the same place. And z-axis, we are going to add a sine angle. Simple as that. If I press play, you'll see our particles will move along, and their directions will depend on the brightness of each pixel. Let's play. You can see now we have a more organic movement. But right now you see our particles are going away from the image, right? It's kind of ugly. So we need to know when the particles quit our bounds, in our case the size image, and reset its position. Instead of resetting to the beginning position, I like to do when, for example, a particle quits or go beyond the 10 unity, right? If it goes on this width plus 10, I want this particle, instead of going to the first position, I want this particle to go to this one, just like a mirror or a teleport thing. So, in order to do that, let's name our wrangles first, just to be clear. Wrangle velocity brightness, and let's place another friend pop wrangle. And this wrangle will check bounds. So I want to give a new position when they quit the image size, right? So it's pretty simple. We will use if statements. So if the position on x is greater than 10, if this particle is above 10 on x axis, we want to teleport it to the other way. So let's just change to -10. So this particle will automatically go to this side. And we want to do the same but the other way around. So else if position of x is less than -10, we want to place on the other side. And we need to do the same exact thing but for the z-axis. So again, else if change the x to z. If point z is greater than 10, just change that position to -10. And the last one, is less than -10, point C will teleport. So now, if I press play, you'll see our particles will stay always inside this square. Again, we are using 10 and -10 because it's the size of our grid. If I press play, you'll see our particles will always stay inside this square, right? In order to see the trails, let's put a trail node. And the trail length, we are going to use the last value. Instead of placing 300, because it can change depending on your project, you can use $fend. And this value, this function, will always pick the last frame number. If you change your project to end in 150, that value will automatically change to 150. And now you ask, why are we keeping the result type to preserve original? Because on the first part we did connect polygons and draw splines, right? We are not using that because right now with checkpoints our particles are going to be teleported to the other way, to the other side. And by doing that, if we draw a spline between the previous position and the new one, we are going to get these straight lines. You can see this grid here, right? That's because our particle that's going beyond the bound is going to be teleported and then draw a spline. Instead of drawing splines with connect polygons, we are going to use preserve originals, and instead of using splines, we are going to use particles, points. Okay, just use that in mind when you are going to render. You are going to use particles and not trails. Okay, in case you are using like Octane or Redshift. Okay, for now, our particles are changing the color depending the position, and we don't want that. Let's turn this off because we have the color map changing the output color. We don't want that. So right now our particles are all black and moving with the source image. Okay, so let's add a color node. Could use pop color inside the pop net, but we don't want that. And right now my points are way too big. I can see them. But they are way too big. So let's go to this eye icon or press D on your keyboard. Go to geometry and change the point size to 1. Just to reduce the point size on the viewport. Okay. One thing I like to do is that, as you can see, our particles are moving way too fast. Let's change the background so you can see it better. Okay. Our particles are moving way too fast and we are getting this pixelate stuff, this effect, and we don't like that. So inside the pop net we are going to add a speed value here. Let's create a float, call it speed, and let's create a channel, call speed multiply. If I press this icon, you can see here you have a new channel called speed multiply. And we are going to use that speed here. Let's multiply these values with this. If I press play now, our particles will move way slower. See? Of course, if you want you can play with this. I like to keep it on 0.1 so they will move really slow and don't have that space. If I place 1, they are getting that space because they are getting a lot of speed between each frame. So I'm going to change it back to 0.1. Now we have more uniform line of particles. I don't like this with a lot of particles, so let's change it to 8000 maybe. To have more space between particles. Okay, so we have our flow with an image as a source. You can change the image from the color map anytime you want. Let's use maybe this image, right? Let's change to, I think it's W7. It's upside down, sorry. You can see. Now it's using that photo from the image. As you saw on the thumbnail, my particles are not going horizontally and are going up. I did that because we will get better results on the face. In order to do that, we can go to the point triangle and simply change this. Instead of using the cosine on the x, I'm going to switch and use sine on x and cosine on the z. And like that, instead of using the 0 starting here, the value, we are going to use, like, rotate 90 degrees. Okay, if I press play now, our particles will go up and we will get better results on the face. You can play with that just as much as you want. And now you ask me how we color them. Instead of using only a simple color like white or red or something, I want to color it with another image. In simple, because we are not changing the color inside the popnet. So before the popnet and after the scatter, we can do these two ways. You can use another image. Where is it? Attribute from map. Attribute from map. And as we did on the first tutorial, you can link an image here. Place this one. I'm going to use another image to color our particles. You can use an image to do that, or you can use another VOP to do that. So let's place a VOP, point VOP in this case, and wire this in. Why are we doing this outside the popnet? Because we want to give colors depending on the position of each point, but only at the start, because if we do inside the popnet, that position will always update each frame and that will change the particle color. That's why we are going to use before the popnet and outside. So as we saw before, and as we learned on the previous tutorial, you can place a scroll noise, for example, wire the position and link it to the color. Now we have our RGB color, right? We can change that with a ramp node. And with this ramp node, we can change the gradient of the colors we want. As for now, I want to decrease the frequency of the noise. We don't care about the Y, but okay. Go up, and now outside the point VOP, we have access to this ramp value, right? The gradient. So you can come here and just play with it. As many colors as you want. I want more white. This. So just play with this one, with the colors, and this way you can give colors to your particles. By changing the noise frequency, you can adjust that. Let's go back to 111 so you can see the noise in function. Okay, this tutorial was pretty simple, right? With just a few nodes, you can control your particles with an image. So that's it for this second part. Now you know how to use simple vex to control your particles and color them. On the next part we are going a little bit further and use more complex vex programming and add a little bit of artificial intelligence to our particles and turn their movement into flocking. If you like this video, don't forget to hit the subscribe button and check out our Patreon page. You can get access to project file, request art studies and vote the topic for the next tutorial. We are trying to reach our first Patreon's goal, and with your support we will be able to keep doing these free tutorials for the community. And believe me, even $1 makes a difference. So don't forget to check out our Patreon page, the link is down below. Hope you enjoyed this video and learn with us. See you on the next tutorial, where we'll be learning how to add flocking to our particles. Hope you have a nice day and see you.